Today we're going to look at perfect squares and the difference of perfect squares. A perfect square is the product of any rational number or expression multiplied by itself. So 9 is a perfect square because that's 3 squared. 3 times 3, it's a rational number multiplied by itself and it gives 9. A squared is a perfect square as well because it's a times a. It's an expression multiplied by itself. 2y is an expression, and so 2y squared is a perfect square. X minus 1 all squared is a perfect square because this is an expression that's squared. And here 3 minus 2y all squared is an expression that has been squared, so it is a perfect square as well. All of these are examples of perfect squares. So if we do a binomial expansion of a perfect square that is a binomial perfect square, that is, there are two terms to the expression that is then squared, we can see that a pattern emerges for every problem, every expression of this form. So a plus b all squared is the same as a plus b times a plus b. And we know from binomial expansion that we can do a times a, which is a squared, plus a times b, plus b times a, plus b times b, or b squared. So we get a squared plus ab plus b, a plus b squared. ab and ba are like terms. They have the same combination of variables. A times b is the same as b times a. So we've got 2 lots of that, 2 lots of ab. So those can be combined. Those like terms can be simplified to 2ab. So we get, for everything that looks like some value, some part of an expression plus another part of an expression, then all squared is the same as a squared, the first part of the expression squared, plus 2 times the both parts of the expression multiplied together, plus b squared, the last part squared. Okay, and we can see a similar pattern with a minus b all squared. So this sort of format. You can see the only difference is these 2 terms are being added and these 2 terms are being, it's the difference of these 2 terms. They're being, the b is being subtracted away from a. So that a minus b all squared is the same as a minus b times a minus b, a binomial product. And we can do, once again, a times a is a squared, a times negative b is minus ab, minus b times a is going to be minus ba, and minus b times minus b, or negative b times negative b, negative times negative is a positive. So we get positive b squared, or plus b squared there. So the general form here, because ab, ba are like terms, minus ab minus ba is the same as minus 2ab. So we get a squared minus 2ab plus b squared there. So anything that we see that's of this format, where it's a perfect square with 2 terms, and the second one is subtracted away from the first one, we get this sort of answer for that, this sort of this format when we expand it. That's what it's always going to look like. Now, if we have a look at here we've added them together, here we've subtracted them. Now, here we're going to look at having a plus b, this is a binomial product, a plus b times a minus b. So here is a different format altogether. We've got one adding and the other one subtracting. If we expand that out, we get a times a, which is a squared, a times minus b, which is minus ab, then plus b times a plus ba, and then b times negative ab, which is going to be minus b squared. B times negative b minus b squared. So here we can see we have minus ab plus ba. So they will in fact cancel each other out. If we subtract, if we're at negative ab, and then we add ba, we're back to 0. So that's the same as adding 0 to that, and we're only left with a squared minus b squared. And this answer right here, this form, where we have one number squared minus another number squared, it's called the difference of 2 squares, or the difference of 2 perfect squares. That's why I've put it in brackets here. Sometimes you'll hear it, the difference of squares, difference of 2 squares, or difference of 2 perfect squares there. And you can see that it is. It's a difference of this is the first square, and we're subtracting this square away from it. It's the difference between the two. It's the difference of one square to the difference of another. And this, if we look at going the other way, and we'll be looking at that in another video, where we actually find things in this form, and then we can actually factorise it and make it look and kind of go in the reverse direction. So if we have a look at a couple of examples now, we've got here one in the format of a minus b. Here this is a plus b, and here this is another one of those difference of two squares that we're going to get. So we can have a look at expanding this out. X minus 2 all squared. That gives us x minus 2 times x minus 2, a binomial expansion here, or a binomial product that we can expand. And that's going to get x times x plus x times negative 2, x times negative 2, minus 2 times x, minus 2 times minus 2. So here we get x times x is x squared, x minus 2 is minus 2x, minus 2 times x is minus 2x as well, and minus 2 times minus 2 is going to be plus 4, because we've got a negative times a negative, it's going to be a positive. Here we've got like terms, negative 2x minus 2x, so it's going to be minus 4x, and we can see that this is in the format of a squared minus 2ab plus b squared. So if we have a look, a is x, so it's going to be x squared, minus 2 times a times b. So minus, we've got the minus 2 times a, so 2 times x times b, which is 2 as well. So 2 times x times 2 is going to be 4x, and we've got that, subtract 4x. And then we have plus b squared. So b is 2 here, b is 2, and we see it's in that same format. B squared, 2 squared is 4. So we can see that it has come out in that same format. Let's have a look at this next one. So this is the format of a plus b. This one back up here was a minus b, and this is a plus b. So here a is going to be 2x and b is 3. So we've got this as a binomial product is 2x plus 3 times 2x plus 3. 2x times 2x is going to be the first part of the expansion, then 2x times 3, 3 times 2x plus 3 times 3. So 2x times 2x is 4x squared, because we do the 2 times 2 is 4, x times x is x squared. 2x times 3 is 6x, plus 3 times 2x, which is 6x as well, plus 3 times 3, which is 9. Then we've got like terms here, 6x plus 6x, that's going to be 12x. There. So we can see that this as well is in the format of a squared plus 2ab plus b squared. Different to the one before, because this is a plus b and that one was a minus b. So here a is 2x, so 2x is a, 2x squared is 4x squared. So we start out with the 4x squared plus 2ab. So 2 times 2x is going to be 4x times 3 is 12x. That's our second term there. And then we've got our b is 3, and b squared, 3 squared, is going to be 9. So we're left with 9. So we can see that this is in the same format there. And once you've had enough practice of doing the expansion, you should just be able to do it in one step almost by going, okay, well this is in the format a plus b, it's all squared, so that means the expanded form is going to be a squared plus 2ab plus b squared. Let's look at this last one now, and let's see if we can get the difference of two squares, because that's sort of what the format's looking like. This is here a minus b, and a plus b. Note that these can be in any order. We can get a minus b times a plus b, or a plus b times a minus b, because we can switch them around and the result will be the same. So here we've got, if we're expanding this out, doing the 3x times 3x, here, then 3x times 2y, then we've got minus 2y times 3x, and then minus 2y times 2y there for the full expansion, for the full binomial expansion there. So 3x times 3x is 9x squared, because we've got 3 times 3 is 9, x times x is x squared. 3x times 2y, 3 times 2 is going to be 6 times x times y, so it'll be 6xy. And then we've got minus 2y times 3x, that's going to be minus 6xy. And here we've got minus 2y times 2y. So it's still going to be subtract, because it's not a negative times a negative. Still be subtract. 2 times 2 is 4, y times y squared. So here you can see we've got the 6xy minus 6xy. So that, subtracting this away, is going to be 0. So this whole part of the actual expression will equal 0. So we can remove that. It cancels out. Okay. So then we get 9x squared left over, and then subtract the 4y squared. Remember that it's always the sign that's out the front of the term to know what is carried down. So it's not the add here, that's the part of the plus 6xy. So we're left with 9x squared minus 4y squared. And let's see if this is in the format of a squared minus b squared. Let's see if it's in that format. So a here is 3x. A is 3x. 3x squared, 3x all squared is 3 times 3, 9. X times x squared, so 9xy. Let's just check what b is 2y, so we're subtracting away. B is going to be 2y, so 2 times 2 is 4, y times y squared.